were talking about 3D shapes last week. Who did the homework? Who did the homework and took a screenshot of that question that we looked at last week, end of last week, Thursday, of the bucket? Does anyone remember that? Did you guys do your homework? Eyeball. At least there's one there. Yes, well done, Eyeball. Maybe you can help me explain this question tonight. Welcome. Glad to have you here. If it's the first time, we are. Bianca's running. Bianca remembers the question. She's already out the door. Welcome if it's your first time. Glad to have you here. All right, let me show you the question. All right, this is why Bianca's out the door already. We're talking about 3D volume shapes. All right, and they have here a cylindrical bucket. Remember, there's three shapes that we talk about: cylinders, triangular prisms, and rectangular prisms. So here is a cylindrical bucket. But now there's a lot happening here. Numbers everywhere, all kinds of strange things. We've got inches here, centimeters cubed there. It looks a bit funny, all right? Not something that you're used to. But let's have a look. All right, we got someone with a question already. Retabile. Oh, the hand went down. Retabile, you there? Oh, that hand went down. All right, feel free, guys. If at any point you want to ask a question, just use the welcome. Pumalele, welcome. Good to have you here. All right. Yes, we got someone that's raised their hand. Yes, there we go. How you doing? You all right?
I'm good. So, it's my first time here in this class, so
Good to have you here. Welcome. What grade are you in? All right, I think it must be a matric student. Sounds like they know what they're talking about. Pumlelo, welcome. Hope you're okay and you're warm. Grade? Grade 11, excellent. Okay, we've got quite a few grade 11s here. And the grade 11s are smart, eh? Grade 11s are smart in this class, so let's see how you do. Let's see how you compare to these grade 11s. We've got some interesting questions tonight, so let's see how you do.
For this question that you gave the others, right? Are we
Yeah.
supposed to view the conversion rates as well?
I'll give you all the conversions you need, but I haven't shown you the question yet. I'm just showing the contextual part of it first, and then I'll show you the questions. I'm just reminding the people of what they saw at the end of last week, Thursday, in the last lesson. Some people saw this and wanted to leave. They were running already, like Bianca's like, I'm out of here. I'm not dealing with this bucket thing.
Yeah.
But I'll show you the questions now. All right.
Okay, thank you.
All right. Awesome. Glad to have you with us here. Good to have new people, new blood in the group. It's fantastic. Right, so here's the scenario. Let's read it one more time. A 20,000 centimeter cube cylindrical bucket has a diameter of 10.5 inches. And they give you the imperial to metric conversion there. 1 inch is equal to 2.54 centimeters. We're probably going to need that, all right? Because if you can see here in the question, we've got a unit of centimeters cubed. And you guys, when you saw this, told me that this number here, 20,000 centimeters cubed, is volume. That is a volume. All right. Someone said it already in chat. It's volume. So the centimeter cube is volume. And then we've got inches in our drawing. We're going to have to convert somewhere along the line. You know that. Okay. Cube 3 times Tondo. Yes, exactly. Oratita, I haven't put any quiz results yet. All right. There's a problem with the quiz results, so we haven't put them on yet. Sorry. We'll try to get them for you on Thursday. All right. So here comes the question, and it's a big one. It's only one question. There it is at the bottom. Determine the height of the bucket. The H you see here on the right-hand side, this H, what is the height? Now, this is a volume question, and they're asking us to find out height. What is going on here? I'm going to give you a clue. if we're dealing with volume, if the question gives us volume, like we saw there in the top of the question, the top there, the 20,000 centimeters cubed, if they're giving us volume, it is a volume question. And for a 3D shape like this, we need a formula. Who can tell me what the formula is? Raise your hand. Someone out there, tell me what is the formula for a cylinder? The formula for a cylinder, please. Anybody out there? Somebody. Kagiso.
Good
Kagiso,
afternoon.
good afternoon. How are you?
I'm good, and yourself?
I'm good. Do you know the formula for a cylinder?
Pi r squared times height
Good. Pi times r squared times
times
height.
height.
Kagiso, thank you very much. On the money. Thank you, Kagiso.
Thank
All
you.
right. Okay, so now we have a look at this formula. All right. We've got V for volume. All right. We've got pi. And we all know that pi, the symbol, they give us the number. You should know the number. It's 3,142. That's what it always is. All right. So we got that done. R is radius. We need a radius for this thing. So what are we going to do? Somebody out there, tell me, how are we going to get the radius? Kagiso, are you still unmuted? Tell me. Oh, no, Kagiso's gone. Anybody else out there? Kagiso is back. Sorry, I'm mispronouncing your name. Yes. How are we
I think it's the radius.
Yeah.
We're going to use the 10.5 inch.
Yes. What are we going to do with it?
Well, if we're looking for the radius, which are we looking for the red D or the radius?
Radius R.
Maybe we're going to say 10.5 squared.
Okay, so that they gave the 10,5 they gave us is a diameter. Hey, so in the question they say that is diameter.
Oh, so we're going to
So
say 10.5 divided by 2.
excellent. So we need to divide that thing by 2 first of all. So we need to take the diameter, which is D, which is 10,5 inches, and we need to divide it by 2, right? Because to find radius, you say D divided by 2, diameter divided by 2. So 10,5 divided by 2 gives us 5,25, if I'm not mistaken. It should be right. You guys can check me. All right. Kagiso, you still there? All right, Kagiso's gone. So we got a radius of 5,2 inches. Now what, people? Now what do I do? I've got 5,2 inches as a radius. Am I good to go? All right. I've got someone who wants to give input here. Excellent. All right. Abo, you there?
I am. So how are you?
Fine. And you? What do I do with this 5,25 inches?
You multiply by 2.54.
Good. We're converting it, right? Excellent. So we need to multiply by 2,54 to get centimeters, because we need to pick a unit for this question. We've got inches in the diagram. We've got centimeters cubed in the question. We need to pick a unit, and it's safe to say that the volume of centimeters cubed means that they're pointing towards using centimeters here, especially with the conversion that they gave us here, also in centimeters. So let's work towards centimeters. So we're going to take the 5,2. In fact, let me write it all down here in a nice big space. All right, so the first thing we did was we took the diameter, which was 10,5 inches, and we divided it by 2. That gave us 5,25 inches. Let's write it down. I want the marker to give me all my marks. All right, sorry, that's not D, that is R. Radius equals diameter divided by 2. In fact, let me write the formula so we all can see it, so you guys can see what I'm doing. All right, so now we take this radius of 5,25 and we convert it like was suggested, times about 2,54. Oopsie, is it 2,54? Yes, 2,54. And that will give us centimeters. And we'll get my calculators to do the work. That's why I bought this thing. 5,25 times 2.54. That gives me 13,335. 13,335 centimeters. All right. I have a radius. I have a radius. Yes. Thank you, Tando. Now what do I do? What do I do now? I've got the formula. I know the formula for this thing. V equals pi times r squared. And I've got an r now equals, sorry, times h. Now what do I do? I'm making you guys do the work. You're like, what? Why does he keep asking us? Yes, I know what to do. I know what. Oopsie, that's the second question. Don't even look at it. Bianca's going to freak out. All right. I know what to do. You guys tell me what to do. You show me what you know. There's the formula. All right. I'm going to fill in what I have, and I'll help you. That'll help you out. I'll fill in what I have. I have a volume. They tell me V for volume is 20,000 centimeters cubed. Pi is 3,142. The radius is 13,335. That's what I have. 5.213. Yes, thank you, Tando. All right, we've got someone else that wants to give some input here. Yes. Yes. What must I do here? Unamdolo, you there? Unamdolo, you there? Hello? Okay, I think Unamdolo maybe pressed the wrong button there. Unamdolo, you there? All right. Let's see, Bianca. Oh, Bianca's still with us. She hasn't gone. Bianca,
Hi, sir.
you still with us?
Yes, I'm still here, sir.
Oh, no, you're not that afraid. You handle these challenges very well.
Yes, sir.
What must I do? Yes, look at this thing. What must I do here?
So, sir, I think you need to take the 20,000 centimeter cube. I need to, okay, let's say you multiply 3,142 multiplied by 13,35 centimeters, and it gives you 41,89857. I don't know if I've calculated right.
Okay, you got it on your calculator. I'm checking on mine. Hold on a second. All right, so I'm saying 3,142 times 13,335 squared. That has to be squared. Or check the calculator. That should be right. 3,142 times 13,335 squared. All right, I'm doing that part to get this horrible looking number. Here it is. I'll write it out. 558,71558,717 431.
Yes, and then you need to divide that number by 20,000 cubed to get your height.
Okay, now you're on the right track by saying divide. Okay, so what Bianca's suggesting is we need to find this h and get it by itself. All right, now what we're doing right here at this point in the sum is called manipulating the equation, because this is an equation, right? And we are manipulating the equation. We're changing it. We're moving things around in an equation. Now, that's core math stuff, I know. All right. But unfortunately, you will have to do some of this in math literacy. Here is an example. When they give you the volume and they need you to find a height, you will have to manipulate the equation a little bit. So think of it like this. This h here with a red arrow needs to be by itself. Unfortunately, it's attached to this horrible number, 558,717,431, using multiplication. It's attached to that number by multiplication. So Bianca said the right word. She said, sir, use division. Because if it's attached to that number with multiplication, you use the inverse operation, the opposite operation, to get rid of it. Okay. For example, I'll give you an example. I know you're thinking, what is he talking about? I'll give you an example. 4 is equal to 2 times h. All right. Same thing. Just simpler numbers. It's the same thing. All right. How do I get this h by itself? Well, I can say divide by 2 because 2 divided by 2 cancels out, doesn't it? But what you do on the one side of an equation, you have to do on the other side of an equation. All right. So now the h is by itself because we cancel the 2 by using division. And now we just have the answer 4 divided by 2 is 2. Okay. All right. Now, Bafana, that's fantastic. He tried out dividing by the 20,000 and he saw it was a very small number and he looked at the numbers and it doesn't look right. Okay. Well done, Bafana, for checking that. So what we're going to do here is we're going to look at our, oh, someone's got their hand up. Let's see. All right.
Sorry to interrupt, but like
No,
I'm not really following what we're talking about here because I don't know if it's because I wasn't here for the last lesson or it's because like I really don't know because I'm
okay.
not really not following.
All right. Let's go up a bit. I want you to focus on this. I want you to focus
Yes.
on this. You see that formula?
Yes.
Are
Pi
you
times R square. Yes. I'm
are
familiar with this
you
formula.
familiar with that? All right. Okay,
But
cool.
then you see what? Yeah, I'm familiar with the formula. Yes.
All right. Hold
But
on.
then,
Let me walk you through this now. So usually what the
mhm,
question asks you to do is to work out the volume. They say
mhm,
determine the volume, use this formula, and
mhm,
then we know what pi
mhm,
is. They give you a radius and they give you a height. Yes.
yes.
And then you put it all into the formula and you use the calculator and you get an answer for the volume.
Yes.
Now, this question is different. What they've done is they've given us the volume.
Giving you
We
the
we
volume.
know what
They've
pi is.
given us
They gave us the volume. We know what pi is. We found the radius, but we don't know h. So we can't use this formula the normal way of just saying times on the calculator equals, that's the volume.
mhm,
We've got to treat this equation a little bit differently now. Okay, so what Bianca's suggesting is, she's saying, sir, if this is the equation so far, are you happy that we've got to get these numbers so far? We took 3,142, we times it by the radius squared, and we got this horrible looking number, 558,717,431. So this is what the
yes.
equation is right now. And Bianca is saying, sir, we need to
Mhm,
get the h by itself because we're trying to find h. So I'm telling
mhm,
Bianca, I'm saying, Bianca, you suggested division, which is absolutely right. This h is connected to this horrible number with times. So to kick off and to kick that number away and get rid of it, we must use the opposite of times. So we will use, like Bianca
what
suggested,
division.
division. So
Yes.
I'm going to divide by this horrible number
Right. Number. Yes.
to get rid of it so that my h is by itself. You happy with that?
Always an enlightened. Yes.
All right.
Yes.
But the problem is, remember with equations, what you do to the one side of the equation, you have to do to the
You
other
gotta do
side of
to
the
the
equation.
other side of the equation.
Yeah.
Yes.
So we got to divide this other side by 558 horrible 717,431. Okay.
Okay.
Now
Thank you.
the h pleasure. Now the h is by itself. We got rid of that number. The h is by itself. What does h equal? It equals this. Okay, so I'm going to get my calculator out and put in these horrible numbers and tell the calculator, do your job because I bought you at the shop, you must work for me. Divide by 558, 717,431. 35. 35. All right, so they're telling us that the height is 35. I'm going to write the whole thing out. 35, 79626. 35, 79626 centimeters. Let me check that number again. 35, 79626. All right, now we got a question. I love it, guys. All these questions.
So weren't you
Yeah.
supposed to cube the 20,000?
What about the 20,000?
Weren't you supposed to cube it?
Cube root it.
No, like put the 3 at the top.
This, are you, when you say the 3, are you referring to this 3 here?
Yeah.
Okay. I'm so glad you asked this. I'm so glad you asked this. Thank you for asking this. Now, I need to bring this to your attention. I get scared when I write units into a formula. And number one, I get scared for 2 reasons. The first reason is because if I don't show my units, then Kia is going to get on my case. All right. So this is why you see units in this equation. But I get scared to write units in this equation because we've got some funny things happening here. You guys are used to working with numbers, but look here. We got centimeters cubed here, and then we've got centimeters here and a square there. All right. Now, like, what must I do? Okay, so that can be very, very, very confusing. So on the left-hand side here, the centimeters cubed, this whole thing here is not a mathematical problem that needs to be solved. These are units. Okay, these centimeters here are also units. The 2 is a math operator, to use a fancy word. In other words, a math symbol, something you have to do. It's like times, divide, squaring is another thing that you have to do to numbers. Okay, so we have to make sure that we separate the units from mathematical operations. So I totally get away. I said, sir, hold on, there's a power of 3 there. Aren't we doing something similar to what we did with the radius, squaring the radius? Now we've got to cube the 20,000. We don't need to cube the 20,000. That 3 belongs to the centimeters. It's part of the units of this number. All right. This 2 here on the right-hand side is not part of the units inside that bracket. It's an operator. It's a mathematical operator that needs to be done. Okay, so you've got to be careful with that. This is why I get very worried when I write units in here, even though Kia says it was always show you units. I do always show me. The reason why I also put centimeters in here to make sure that we're working with centimeters only in this equation. We need to work with the same units in this equation, which is why I wrote them in there. Kagiso, you got a question? Oh, sorry, Kagiso. Sorry. Just check there. Yeah, there we go.
Yes, I wanted to ask, why are we dividing using 558 and not using 20,000 centimeter cube?
So you wanted to divide by 20,000 centimeters cubed.
No, I just wanted to know, like, how do you know which part do you divide with and which part do you not
All
divide
right.
with?
Good question. Because this is core math thinking, and we're trying to apply it here in math literacy, which is very frustrating. You know, when you leave core maths, you walk away from it. It's a bad relationship. You don't ever want to meet that person again because they weren't nice to you. All right. It's a horrible relationship. You don't want to talk to them, don't want to see anything about them, don't want to deal with them. But unfortunately, we got to bring this core math thinking into math literacy here, because you're going to have to learn how to manipulate equation especially in measurement when you're given these long formulas. All right, so I'll give you another example again. Let's do this. Let's say we had h. For some reason, we had a formula where it was h divided by 2 is equal to 10. All right. For some reason, I don't know where this formula comes from, but they gave it to us. We put the 10 in, we put the 2 in, and they said, find the h. All right. How do we get this h by itself? I'll show you. This number that is underneath the h, the 2, it's with the h, and we want to get rid of it. How is it linked to the 2? What mathematical operator is linking it to the 2? Division.
Yes,
So how will we get rid of that 2?
if we divide the 10 by 2. On the other
Okay.
side, if we use the 2 as the same way the 8 is divided by 2, on the other side, we also have to say 10 divided by 2.
Okay, you're right. if you do something to an equation like divide by 2, then you must do something to the other side as well. Yes, you're right. But this equation, I never did this divide by 2. It's given to you like that. So I haven't divided by 2. It's just presented to you like this. And they say, get this h by itself. Now, the divide by 2 is there. I never put it there. It's given to you like that. We've got to get this h by itself now. It's got divide by 2 on it. So
Okay.
if it's divide by 2, we've got to use the opposite maths operator of division to get
Which is
rid of that 2,
multiplication.
which is multiplication. So to get
So
rid
we're
of that
supposed
2,
to say,
we
say
must
h
times, yes, we times the side by 2. And when we do something to that side, we
it
do
goes to the
something,
other side.
yes. Okay. So this timesing by 2 here that we've done
Going to cancel.
cancels that divide by 2. That's why we're doing this. You see.
Oh, okay.
Now watch, I'll prove that it works. So now we have h by itself, and we have 20 on the other side here, yes? All right.
Okay.
So
Thank you.
I'm gonna hold on, let me just rub this out. Let's change
Okay.
h to 20. 20 divided by 2 is 10. All right.
Hello, sir.
Yes, I'm listening.
Okay. I have a question.
Tell me.
So, like, right? Remember, you see when you calculated the 200,000 centimeters cubed over
No,
500,
20,000.
500, 20,000. Thank you. 20,000 centimeters cubed, right? Over that freakish number
That
that you
horrible,
said.
that freakish number.
That
Yeah.
horrible number.
That horrible number.
That's horrible number, yeah.
It looks a
So
horrible looking
then,
thing. Yes. There it is on my calculator. There it is on my calculator. So I did 20,000 divided by 558,7. Now this thing on the right hand side here that you're seeing, 558,717,431 divided by 558,717,431. Those two things will cancel out. This is why we're doing this. This is why we're doing this divide by this horrible number, so that it will cancel out the
And so
horrible
that the
number.
h can be left alone.
And we want the h by itself. Okay, so that's why we do
Okay.
this. All right, that's why we're doing this. It's called manipulating the equation, or moving things around in the equation. And it feels different because you are used to getting something like this: length times breadth times height. They give you a length, they give you a breadth, and they give you the height. You say times on the calculator, and out comes the volume. But in this question, they gave us the volume, all right, which changes the question now. So if they give you the volume, the length, and the breadth, and they say, what is the height? You've got to now change this equation to look a little bit different to make this work for you. It's called manipulating the equation. You don't need to manipulate the equation. If they give you length, breadth, and height, you don't need to change it. You just put in the calculator, it does the work for you. But if they give you volume and they want you to find something else, you're going to have to manipulate the equation a little bit. So that's what we're doing here tonight. All right. Now, I've got another question exactly like this for you guys to practice. Okay. But before I do, is everyone okay with this? Are we all good? Speak now, never hold your peace. That's what Kia says.
Never
Yes.
ever hold your peace.
Never ever hold your peace. All right, we got a question.
no, okay, I understood that part that you're talking about, right? My
Yeah,
question is, after finding the heights, my teacher told me that we should always like round off to like the nearest two decimals. Are we
your
supposed to do that as well?
your teacher is absolutely right. Kia, Kia also gives me gears about this. Like, make sure you're rounding off. So the second, I'm falling short tonight. So the second decimal here is the 9. The 6 will change it. So you're absolutely right. This is not the final answer, because the instruction in the exam will be round off to 2 decimal places unless told otherwise. There we go. Sure. All right. Okay. Are there any other questions? Are we good to go, guys? Can we move on to the next one, or we can still chat about this? I don't mind. Yes.
Just look for a message on your screen. There we go.
Hi,
Hi, how are you?
I'm good. How are you?
Good, thank you.
I'd like to ask a question about the decimals. Is there a need for us to write all the decimals, or we could just write it into 2 decimal places and round it off?
Brilliant question. I was thinking about that when I put this number in here. When I put this 13,335 in, I know some of you are thinking, why did he put the whole thing in? Why did he put it round that off to 2 decimals? Why write the whole thing? I'll show you why. I'll show you why. If we chop off that number, right, and make it 13,34, look what happens to the sum. Okay, I'm going to go back up to my calculation. There it is on the calculator there. This is where we said 3,142 pi times the radius squared. Now, if I go back into that part and I change that 3 decimal number into a 2 decimal number and round it off, look at the number we get now. Look at it carefully.
It's going to be 559 instead of a 558.
Yeah. And that error there, that change there will lose marks in the final answer in the exam. Now, why do you have to be careful? Usually you don't, especially if you're adding 3 or 4 or 5 decimal numbers together, you don't really have to worry. But if you're raising a number to a power of something else, a small little change in that number results in a big error down the line. So we always recommend that you never, ever, ever round off in a question, only at the end. I know what you're thinking, sir, come on, look at all these decimals. Do we have to really, really write all this? Maybe you can chop off the 4th and the 5th and the 6th one. All right, I'll be okay if you chop that off there like that. But if you are raising that to a power, you chop things off and then you raise it to a power, you're going to get errors down the line. Your errors become amplified with the power of 2. Okay, so try and keep the decimals as much as you can. As much as you can. All right. Does that answer your question?
Thank you so much.
All right. There's another question here. Safiso. Check your screen there. Yes, Safiso.
Excuse me, so can I please ask about the 13,335, right, sir?
Yeah, yeah.
Is it like a must to put it in brackets and square up, or what?
No, you don't have to. You don't have to. If you've worked with me, you know I like brackets. Okay, it for me it visually isolates things, and it's telling me that number must be squared. I can write this whole thing out again for you without a bracket. It's not going to change it. Or I'll do it for you now to show you without a bracket. So 13,335, and then I just put the power of 2 there like that, and you should get the exact same number. So the bracket doesn't make a difference. It's just a thing I do. All right. So when I have certain calculations that look different, I usually put brackets around. You don't have to. It's not going to make a difference. Good question.
Thank you, sir.
Thank you. Good question. All right. Miss Kia, there's a question for you coming. All right. I'm going to move on to the next one. In fact, let's take a break. Let's take a break, guys. Let's take a break now before I show you the next one. All right. Otherwise, we're going to have people leaving. Like Bianca is just going to walk. Tiamo is just going to walk. Is Tiamo here tonight? Ooh. I don't know if
They're
Tiamo's
gonna
here.
first start by dropping emojis.
They're going to drop
and then they're
emojis
gonna walk.
and then they're going to walk. All right. So let's just take a break and breathe. All right. There's a lot that's happened here. I've got another one very similar. We're going to do a similar question, but please, there's Tiamo. Glad you with us, Tiamo. We love you, Tiamo. All right. Please don't go. Please don't go. All right. So let's have a break. I have a question for you, not a mathlet question. Please tell me, is the first week of school harder or is the second week of school harder? We're in the second week now. How cold? Oh, it's cold. But I have a question. Is the first week of school harder or is the second week of school harder? Please explain it to me because I'm feeling like the second week is harder. Kagiso.
I think the second is harder because the first week is just everybody is like meeting everyone. It's nice, and the teachers are just giving us a break as matriculants. And now they're like, you know what? Since it's the first week, we're not going to really put pressure on you guys, but everything is going to be like packed up the second week. And now, like, everything is like stressing, even the prelims and stuff. So the second week is harder.
It is.
Yeah.
It's getting real now. The second week feels like it's getting real.
It's like getting slapped in the face by life. Like, oh my God, this is really
Yeah.
happening. Yo.
Yeah. So I watched
I
my
thought I was
students.
the only one, but I guess I'm not.
No, I agree with you. I watched my students the first week and they were all happy, and then they came back on Monday this week and they were, the faces were down. I said, "What happened, guys? Did you not sleep well this weekend?" It's like everyone was tired. I said, "Did you not sleep well?" "No, sir, we slept well." "Then what's the problem?" "I don't know. Second week is bad. All weeks, guessing all weeks are bad."
Yes.
What a, please ignore the, the TA's negativity. She's working hard. She's a hard worker. Good question. Recorded meetings. Every lesson is recorded, and a couple of days later, it's put on Watobe's YouTube channel. So please check the YouTube channel. If you missed any lessons, they should all be there. So if you missed the first part of this course, then check the YouTube channel. All right. School is a scam. Aibo. School is a scam. All right.
That's the realest thing I've ever heard on here.
I wanted to ask a question. So,
Yes.
if it happens that maybe, will I be able to find the lessons that I'm having on Watobe if I'm not logged in, that I recorded?
Yeah, they can find the lessons on YouTube without being logged in.
People who are not members.
Yeah.
Yeah.
In fact,
Because
we
it
used
is
to.
available.
It's
on
available.
YouTube.
In fact, we used to encourage guys to take the videos and go to their friends just before the exam. So the revision courses, we used to encourage them to say, guys, get the link and go show your friends with this stuff. They were like, "Oh, this is important." Yeah, get the link and go show your mates. All right. So yeah, I don't know if they'll change it in the future, but as far as I know, right now, Watobe's lessons are all recorded. It might change in the future, but it's all free. It's all, anyone can access it. The YouTube channel's got quite a few followers. It's pretty it sees quite a lot of views actually.
It's very helpful.
Yeah, it is. I mean, if you've got something that you found very interesting in a lesson, look, it's an hour long, so maybe your friend doesn't want to watch an hour-long lesson, but get a
I don't think
piece.
it's that long, you know. Sometimes I wish they would actually extend the time. Maybe if it was 2 hours.
Phew. We're gonna do special lessons towards the end of the year that are an hour and a half long. What do they call it again, Kia?
A boot camp.
Boot camp, that's it. They call it boot camp. So we do boot camp lessons closer towards the final exams, and those are an hour and a half long. But
Okay.
2 hours a week is all we're doing for now until you guys want more. So send messages saying we want more. We want more. All right, send those messages through. All right, let's have a look at the next question. Let's have a look at the next one. All right, don't freak out. I'm going to walk you through it. Let's have a look at it. All right, here it is. Let me zoom out a bit. Okay, Pearl wants to install 4 JoJo tanks in her property to grow vegetables. The diameter of one JoJo tank is 1,820 millimeters. Okay, there are the JoJo tanks. She wants to install 4 of these. The diameter of the tank is 1,820 millimeters. Note at the bottom, you see this here? They're giving this to you. You're going to have to use that. They're giving it to you. Let's go down to the questions. Number 1. Determine the radius of the tank in centimeters. Now, I'm going to write it down here. Okay. So I'm going to write the information down here so we can see it. So I'm going to put here R that they gave us in the question 1820 millimeters. All right. So that comes from the question. Determine the radius of the tank in centimeters. That's a warm up. Come on, guys.
Ben is like he's tired.
Who says Ben? Tired. Oh, Ben, don't be. Come on, we're nearly there. We're nearly there. Determine the radius of the tank. It's a warm up. You guys should have answers already. Determine the radius of the tank in centimeters. Easy peasy. Come on, guys. I don't know why I made it 3 marks. It should be 2. Should be 2 marks, not 3. Oh, that's why it's 3. All right. So we got the. Here's its diameter, isn't it? Oh, guys, I'm trying to con you. My bad. Sorry, it's not. That's D. It's a diameter. Eesh. Okay, sorry. Yes, you guys are right. Okay, so first thing we're going to do is we're going to change the diameter to radius by saying D divided by 2. All right, so 1820 millimeters divided by 2, which gives us 910, if I'm not mistaken, millimeters. Okay, but they want it in centimeters. So like you guys have said, so, sir, take your millimeters, divide by 10, and that'll give you 91 centimeters. Okay, now I'm going to draw a little sketch here. So here is our tank. I'm putting all the dimensions on here as we go. All right, please excuse my drawing. So the radius here is 91 centimeters. Okay, that's what we have so far. That's all we have so far. All right, you're all good. You ready? Here we go. 1,000 cubed, 1,000 cubed. Ah, so Tando, that's the thing again. That cube doesn't belong to 1,000, eh? That cube belongs as a units. It's units. All right, so we're not going to cube anything because that 3 is part of the units of that conversion. So don't worry about that 3 yet. Here's the next question. Calculate the height of one JoJo tank in centimeters if it has a capacity of 5,250 liters. Oh my gosh. All right, there's a lot here. The first thing we need to check is we need to calculate heights. Same story as before. Same story as before. If they give us the capacity. Now, you know the capacity and volume are the same thing, right? But volume is centimeters cubed. They're giving us capacity in liters. We're going to have to change it, right? Well, guess what? Look up there. There's something that you can use to change it. All right. Can I leave you on your own? Bianca's like, sir, enough, that's homework. Can I leave you on your own for a few minutes to see if you can get this? Or let's just try. Let's try and see. Let's try to smash this out and see if we can't get an answer here. I'm giving you hints. I'm dropping big hints along the way. Dropping big hints here. I'm just going to bring the tank down. I'm going to bring my drawing down and I'll show you the question again. Excuse me for a second while I bring this down. All right, I'll put it here on the side. There's my tank. And they want to know what is the height of the tank. It has capacity, which we know is volume. All right. It's just a different way of expressing volume. This is liters. All right. Use the same thing. Use the same thing that we did last time, except for this question. The only difference is in this question, they didn't give you volume in centimeters cubed. They gave you capacity with liters. So change it. All right. There's the conversion at the top there. 1,000 centimeters squared, cubed is 1 liter. Do something with that. Beta Bill is back. Excellent. Perfect timing. All right. Do something with that capacity. Change it to volume first. Put it in your formula. Write what you have. Excuse me. You've got power. You've got a radius. You're trying to find a height. And I've showed you how you can do that. I'll give you a couple of minutes, guys. You can do this. All right. We have a question. Yes.
Yes, for like, you see, for the first question that
Mhm.
determined the radius for the tank,
Yeah.
I wanted to know how did we get the diameter for the 108,
The 1,800. That was
1,820.
20.
Yes, the
It was
diameter. How do we get it? Yeah.
it was given in the question, so I'll scroll up quickly. Hold on a sec. I'll
Mm.
Gremlins. Oh, hold on a second.
Nah, my brain. Nah, my brain.
Wait, hold on. All right, guys, I'm gonna have to restart this thingy. Just bear with me. All right, bear with me. I'm gonna have to restart here because we've got gremlins in the system. All right, bear with me. Here we go. We're gonna start this thing up again. Stay with me.
Okay, no problem.
There we go. Where were we down here? All right. So the question said right at the beginning, there it is there. The diameter of one tank.
Okay.
Yeah. So I wrote it down
Okay.
here.
I didn't see
So
that. I didn't see that.
yeah, that's why I moved it down because we were looking
Oh,
down here by the other questions. So there's the diameter there. All right.
okay.
So this is where we are.
Yes.
There's your formula,
So
you got
now,
capacity, you got
so now
radius,
we have
you
to
need
find the
height.
height again.
The same thing as before. Same thing as
Mhm.
before. There's your formula, right? Put everything in
Mhm.
that you have and get that H.
Mhm. Thank you.
Isabella's already excellent. Isabella's got an answer already. Excellent, Isabella. Working in the background there. Give you 2 more minutes, guys, and then I'll show you. All right. Tando's also got an answer. All right, don't worry about the answer coming on screen. You guys carry on, do your thing. Zoom in a little bit. All right, you should have answers in front of you. All right, we got 2 people with answers. There
I'm
should be
hoping
more.
everybody is like typing their lives away on the calculator.
Yeah. Rita Billy also with an answer there. Kagiso's also got an answer there, a little bit different. I love it when the answers are different. It means there's different methods being used. Very interesting. All right, 1 more minute, and then we'll give it a bash. All right. You should have something in front of you. All right, Bafana's got a different answer there. Excellent. We've got different. I love it when the answers are different. So when you check what's on the screen with what you have, we need to see why it's different. Okay, so follow along as we do this. Thanks, guys, for these answers. Follow along now as we do this and see what's different now. All right, so there's the formula on the screen for volume. Okay, we need the volume formula. They tell us to use this formula. Okay, in the volume formula, we need to put in some things to find H. We need to put in radius. Now, the radius units are going to be in centimeters. Okay, the volume then also has to be in centimeters. All right, and the height will come out, sorry, cubed, centimeters cubed. The height will also come out in centimeters. So we have to work in centimeters here. in this question. All right. Unfortunately, they don't give us a volume in centimeters cubed. They give us capacity in liters. So we will first have to change that. So we're going to use this conversion that they gave us in the question to do that. All right. So we're going to say if 1 liter is 1,000 centimeters cubed, then how many centimeters cubed is 5,250 liters? So first thing we're going to do is we're going to multiply our 5,250 liters, because each one of them is 1,000 centimeters cubed. So we've got a times by 1,000, which is going to give us a horrible big number, unfortunately. 5250 times 1,000. Yee. It looks like 5.25 million. Oh my gosh. All right, so 5250000, if I'm not mistaken. 5250000. It's a lot of centimeters cubed. Well, it makes sense, guys, because a centimeter cubed is a dice, and this is a JoJo tank. How many dice can you put in a JoJo tank? All right, so now that's our volume that needs to go into the formula. So let's put it into the formula. I'm going to write this horrible thing all over again. Oh my gosh. That's centimeters cubed. Now that's in our formula, right? That's the volume. We got pi. Radius is 91. Okay. And it needs to be squared. Oh, I'm writing the units and then I'm going to square it. I like to use brackets. Sorry. It's just my thing. I like to use brackets, guys. Don't shoot me down. Okay. You don't have to use brackets. I like to use brackets. Stay with me now. We're nearly there. We're nearly finished for the night. Then you can go have a hot beverage. All right. So now I'm going to do the same thing and I'm going to combine these numbers using the calculator. Okay. So I'm going to say 3,142 times 91 squared. I'll leave the brackets off. Doesn't make a difference. Oi, horrible number. 26018, 902. 26018, 902. Is that right? 26018, 902. All right, that's fine. Times H equals this massive volume. And we're going to apply the same method here. To get rid of this number that's on the H, which is attached with times, we will use the inverse operation, the opposite operation as times, we will use divide. Okay, so we're going to divide by this thing. Divide by 26018, 902. But what you do on the left side, sorry, the right side, you must also do on the left side. You got to do the same thing to both sides of the equation. So now our H is by itself because these two numbers will cancel. All right, H is by itself. What is my H? You ready? 5250000 divided by 26018, 902. Bang. 201,77638. 201,77638 centimeters. Rounded off. 201,78 centimeters. Ah, superstars. 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 Isabella. Isabella has a question. Check your screen there, Isabella. All right, Isabella, just check your screen. There should be a prompt there to unmute. There we go. Yes, Isabella, you with us?
Hi.
Hi.
Yeah, I wanted to say something. I don't want to ask a question. I just want to tell you how I did mine because I think I got something wrong.
Okay, tell me.
Okay, so as I calculated the height and everything, I got 5,250. And then I did the calculations like the pi times the radius and everything. And then I got the 26018,902.
Yes.
But then I equals to 5,250 and then I divided both sides by the 26018,902 and then I got 4,955.
So you got 5250 divided by 26018,902.
Yes.
Okay. So this is what you look on the screen, the calculator. So this is what you ended up with. The height is equal to this. Is that right?
Yes.
Okay.
Yes.
If I press equals, you should get that.
Yeah.
Is that what you got?
No, that's not what I got. I think
Check
I
your
made a
calculator.
mistake.
Yeah, check your calculator again. Check your calculator again. So the only difference between what you're doing and what I'm doing is you've chopped off some zeros, which means your decimal and your answer is in a different place. The numbers 201776, I've got the same numbers, but there's just a decimal in a different place.
Okay, yeah. Now I got 0,201.
Yes. So now what you've done now is we're getting the same numbers in the answer, but the decimals in a different place because you've left off zeros out of your volume. So look at the screen here at the top. So when I changed my liters into centimeters cubed, I used that calculation there. I'm highlighting in yellow, which is why we get this massive number, 5,250,000. You didn't get 5,250,000. You said 5,250. You used that in your calculation. Your methodology is perfect. It's just that one little thing there. You've left off some zeros because I don't know if you times by 1,000 to convert your liters into centimeters cubed. So if you had times by 1,000 there, you would have got it. Okay.
Okay, thank you.
Pleasure. All right, another question. Kabo, check your screen. Yes.
So I really can't understand why you don't cube root the 5 million. Like it's not clicking. I can't lie.
Yeah, it comes back to the difference between units and a math operator. And I'm using fancy words. If I go back up to the previous question here, the best way I can explain it is centimeters cubed is units, is part of the units. And on the right-hand side, yeah, 13,355 centimeters squaring them. Now, the square on the outside of this bracket. This is why another reason why this is why I use brackets actually, because if I don't use brackets, and if I wrote this in my formula like this, 13,335 centimeters, and you know, your teachers tell you always show your units in the formula. So if you write there centimeters squared, and then you know you have to square this, that's when confusion comes in, because now is this centimeters squared or am I squaring to the power of 2 the centimeters? That's where the confusion comes in. So the top one is a unit of measurement. That's area, the unit of area. This one here inside the bracket is length. And we're squaring the length to get a bigger number. That's all. So that's where the difference is. Centimeters cubed, centimeters squared, and centimeters are units of length, area, and volume. But you can take those numbers, the number in front of those units, and raise it to the power of 2 or raise it to the power of 3. That's why I use a bracket to show that. Okay, so in my formula, I've shown that with a bracket here. I've said this number, which is length, radius, needs to be raised to the power of 2. Now, on the left-hand side, that's not raising 20,000 to the power of 3. Centimeters cubed is the unit that we are using there. All right, so you got to get used to centimeters cubed as a unit, centimeters squared as a unit, and centimeters as a unit. And each of these can be raised to the power of 2. All right, but the number is raised to the power of 2. Okay, so you got to tell the difference between units and when you're raising a number to the power of 2. I hope that answers the question. But the more of this you do, the easier it will get, the more sense it will make. Okay. All right, ladies and gents, we're 5 minutes past. We're going to do more of these questions. There's lots more coming. This is week 2 of a 3-week course. We're halfway. We're only halfway. There's a lot more coming. All right. But the most important thing is that you break the question down here to get to the answer. So the more of this we do, the easier it will get. On Thursday, we're also going to do some surface area as well, which is easy. Just sub into the formula and go. All right. But we have to call it a night. Well, one more question. One more question, and then we'll call it a night. Kagiso?
Yes. My mom wanted me to ask regarding the Watobe payment, since you guys offer free days for 14 days, and then after that we must pay. So she asked me to ask you guys how we can work this out regarding payment. And yeah.
The best thing to do is to go to the website, and they've got like a WhatsApp number there with a team that's always on standby to answer those kind of questions.
Okay.
We as teachers, and even Kia, I don't think she even knows how to handle that, but on the website there should be a WhatsApp number, and there's a team that's always on standby during the lessons to ask questions like that. Okay, so just check the website for that number. Okay.
Okay, thank you.
All right, ladies and gents, we've got to call it a night. Will you get marked down for not adding centimeters cubed or squared? No, you won't get marked down. But it's in the answer, it's good to show your units always in the answer. I'm showing units everywhere, and it's starting to cause a little bit of confusion, but I'm showing units everywhere. In the answer, you must show your units. Okay,